In 11.7, we want to convert cylindrical coordinate to spherical coordinates. Let's take number 65. So we're given that r is equal to 4, theta is equal to pi over 2, z is equal to 4. So we know that x is equal to r cosine theta and y is equal to r sine theta. So from here, x is equal to 4 times cosine of pi over 2. And so x is equal to 0. Y is equal to 4 times sine of pi over 2. And so y is equal to 4. So from x, y, and z, we can find rho. So rho would be the square root of x squared plus y squared plus z squared. So x squared would be 0 squared plus y squared, that's 4 to be squared, plus z squared, that's 4 to be squared. So here we get 16 plus 16, 32, the square root of 32, and that's 4 times the square root of 2. Well, after that, we need to define phi. Cosine phi, you recall, is equal to z divided by rho. Well, we have rho, we have z. Z is equal to 4, and rho is 4 over the square root of 2. So we get 1 over the square root of 2. And so phi is equal to pi over 4. So the point in spherical coordinates, rho comes first. So this is 4 times the square root of 2, comma, theta, that's given, pi over 2, comma, phi, we found that to be pi over 4. What about number 67? So for 67, we're given the point 4, comma, negative pi over 6, comma, 6. Again, you recall that this point is given in cylindrical coordinates. So r is equal to 4 theta negative pi over 6, and z is equal to 6. So we have to find x and y, take z to find rho. So x is equal to 4 times cosine of negative pi over 6. Take a 30, 60, 90. Look at the sides, 1, 2, and the square root of 3. So pi over 6, 30 degrees, and we say that to be negative pi over 6. So it's going to put us here in the 4th quadrant. So the actual angle, and you can find that, but here the cosine, and you can glean from that cosine is with respect to x, and the sine is with respect to y. So cosine is going to be positive for this negative pi over 6. So pi over 6, the cosine of that would be the square root of 3 over 2. So this is 4 times the square root of 3 over 2, and x would be positive there in the the fourth quadrant. So this is 2 times the square root of 3. Now y is 4 times sine of negative power over 6. So the sine of power over 6 is 1/2, and in the fourth quadrant that would be negative 1/2. So this is 4 times negative 1/2, or negative 2. Z is given to be 6. So rho is equal to the square root of x squared. So this is 2 times the square root of 3 to be squared, plus the negative 2 to be squared, plus 6 squared. So we get 4 times 3 is 12, plus 4 plus 36. So we get the square root of 52, or 4 times the square root of 13. And that's for rho. So we have rho, we're given theta there, and so now all we need is phi. We get phi from cosine. Cosine of phi is equal to z divided by rho. We just found rho. So z is equal to 6 all over 4 times the square root of 13. And that rho, that's 52, so that's 4 times 13. The square root of 4 is 2. Excuse me. So this is 2 times the square root of 13. Two times the square root of 13. So here we get 3 over the square root of 13, and so that implies that phi is equal to cosine inverse of 3 over the square root of 13. So the point that's converted, rho is 2 times the square root of 13. Theta is negative power over 6. And phi is cosine inverse of 3 over the square root of 13. Thank you.